Yes, good evening. My name is Musa David, and today on this project, I'm trying to review unexplainable machine learning to improve assembly line automation. So this is kind of a review paper that I'm trying to summarize, and I check how it affects the performance of the assembly line automation. Our background is that remember that we have local companies producing power transfer unit, that is PTU, for vehicles, and in this production 3% products are rejected due to mismatch of scheme. This is small mechanic part supporting PTU. We need to remember that the power transfer unit is the PTU, so the consequences decrease the reliability of the system. So if you have to sell something like 20, the over 3 are affected, let me say misalignment, then rather than the rejected, it causes a lot of economic loss. So due to manual prediction of shimmy dimension, the automatic central control from the cloud can't be done. So automation cannot be done, and since these days several countries have announced their manufacturing industry plans. For example, China by 2025 should have implemented its target. So to solve the problems of rejection, decreased reliability of the system, we are going to use shimmy prediction and implement PTU with explainable machine learning. So this will automate the manual shim selection process in assembly line and explain the machine language prediction. ML is machine learning prediction. So machine learning comprises statistical methods that enable computers to perform classification and regression without splitting program. So, and then we are able to predict, classify. So the problems that I'm addressing today, or the review paper is addressing, is because of redundant tasks performed by human experts, which results in accuracy and unnecessary time consumption. So you see misalignment of tires, and this consumes a lot of time. So the products are few produced, and yet in example it is say 50, 30 are accepted and 10 are rejected because of misalignment or damage. So machine language learning, we have also, since we can't do automatic central from the cloud, then machine learning can be used. Then we have the problem of increased rejection rates as consequences, which decreases the reliability of the system. Machine language, the methods that we are going to use, we will have machine learning with hybrid approach. We will combine the k-nearest neighbor and machine learning model. We know that machine learning model, it uses the capacity of predicting automatically by classifying. So then the k-nearest neighbor, we are dealing with proximity, things that are all together. So the groupings of the features, we group in the features and check, then we see what usually happens. So k-nearest neighbor, I'm saying that we make classifications about the individual data point from the features that we use. We are saying that even we follow the use of decision making trees, whereby we use the non-parameter model that has rule inferred from the data features. So they support vector regression and partialist squares, artificial neural networks to find the best combination for both the parts of the assembly line. So if we are dealing with the neural networks, remember we are making a decision using nonlinear and complex inputs. So what are we seeing here in this diagram? We are seeing offline processes, collecting knowledge, data requirements, then future extraction based on domain. Then we come to hybrid approach where we can train, set, correction using of k, nearest neighbor, and regression. We know regression is we are using graphs like this, drawing the graphs so that we can determine the rate, the means, and then we are using also offline and online processes. We are seeing the offline is this side and online process. Online data at manufacturing rate, that's with formatting data regression by hybrid, so meaning it's connected. Basically we are using hybrid approach which combines k-nearest neighbor and machine model. So the results that we are going to get with the introduction, we are going to enhance prediction, which will improve prediction line close to the green line. This here discovered, so this is the green line, meaning good shim. So another result, we are getting good performance measurements and low run time. We also have correctly predicted shim dimension for curves. This one is here. Limitations. We don't have explanation of the prediction. That's so there is no transparency of the whole manufacturing process. Something that is not transparent when it comes to, let me say, documentation. That was also an issue. So the future is we are trying to explain using the explanation identified by Sharp. Sharp is the mean to help tune important features and therefore lowering the detection rate significantly. We can incorporate digital twin and conjective system in the future direction. So the conclusion, the main contribution is to utilize the benefits of machine language by reducing faulty PTUs using a hybrid approach based on shim prediction and shim prediction process explanation for assembly line automation. So we have data set and ML regression models that have shown better performance in terms of accuracy. Lastly, we want to thank Ramos, Bluestorm Stray, and Daniel Jackson for the initial work in the PTU manufacturing domain. References below. These are the references below, and we have ZG, Song, and F. Gao, review of the recent research on data-based process monitoring, industrial and engineering chemistry research, volume 52, number 10, page that. So thank you for watching, and have a good time. Please don't forget to subscribe my YouTube channel. Thank you. Have a good time.